So let me ask you something. Did you learn math the traditional way? The one packed with theorems, proofs, and constantly solving for x? Well, if that's you, then you're in the right place. We're going to talk about how to take all that powerful knowledge you have and update it for today's world, shifting your whole mindset from just solving problems to actually creating things.
And let's start with the question that, let's be honest, might be nagging you a little. After all those years you spent mastering calculus and algebra, you built this incredibly strong foundation. But in a world that's all about AI and big data, is that foundation still enough? Is it really as relevant as it used to be?
Okay, here's the core of it. The big difference is the approach. The old way, we all learned, over on the left, was super theoretical, right? It was all about proving theorems and getting that single right answer. But the new way, on the right, is all about getting your hands dirty. It's about using math to model the real world, to simulate what might happen, and to build actual working systems. It's a huge leap from just knowing something to actually making something.
So first up, the math we learned. Before we jump into all the new stuff, let's just take a moment to appreciate what you already have. The math we learned is not obsolete, not at all. It's actually the bedrock we're going to build everything else on. Seriously, all those hours you put in, they gave you this powerful, rigorous foundation. You get the logic, you see the structure, you understand the why behind the formulas. That is a massive advantage. But while that foundation is rock solid, the world that's been built on top of it has completely changed. And that brings us to our next section. The world has changed. The context where we use all this math has been totally transformed. We have new challenges to solve, and luckily, some incredibly powerful new tools to solve them with. And the new operating system for this modern world is something called computational thinking. Basically, it's the skill of translating mathematical ideas into instructions a computer can understand and run. So it's not just about symbols on a whiteboard anymore. It's about making those symbols come to life as code, so you can model and play with real-world systems. And look, this isn't just some abstract idea. This slide breaks it down. You see a field like artificial intelligence? That's not magic. Under the hood, it's driven by linear algebra and optimization. Modern finance? It runs on statistics and time series analysis. Those massive global supply chains, they're managed using graph theory and simulation. The math is the engine behind it all.
All right, section 3, the new language of math. So if computational thinking is the mindset, what does this new language, this shift from pure theory into code, actually look like day to day? This quote from our source material just nails it. Back in the day, the big challenge was to sit down and find the perfect analytical solution to a differential equation. Today, the much more valuable skill is being able to model and simulate how that equation behaves over time using a tool like Python. You see the difference? One is knowing, the other is doing. And this right here shows you the huge difference in the outcome. The old way on the left gave you the knowledge you needed to pass a test. The new way on the right gives you the power to build a system that solves that same problem over and over again out in the real world. It's the leap from just having knowledge to creating real impact. Which brings us to the big one, section 4, how to modernize. Okay, you see the gap, you get the difference, and you want to bridge it. Well, the great news is there is a very clear path forward. This is your action plan. Here it is, your 5-step roadmap. First, get comfortable with Python and its main scientific libraries. Think of it as your new super-powered calculator. Second, really dive into mathematical modeling. Third, master optimization. Fourth, get a handle on the big AI frameworks. And finally, number 5, start using graph thinking to see the world as a network of connections. It's a clear, step-by-step path. And you are definitely not on your own here. The amount of amazing resources available today is just incredible. You've got top-tier university courses on Coursera and edX, fantastic books, and of course, the endless knowledge you can find on Google, YouTube, and with AI assistants. Okay, I have to specifically call this one out. If you really want to see what this new way of thinking feels like, go watch 3 Blue 1 Brown on YouTube. It is not about memorizing formulas. It's about building this deep, intuitive, visual understanding of the concepts. It's a perfect example of the shift away from just memorizing to actually understanding. And that brings us to our final section, from student to creator. So what does this all add up to? What's the big picture? Well, it's about more than just learning a few new skills. It's about a fundamental shift in how you see yourself.
This is the ultimate goal. This is the promise. It's about taking that solid foundation you worked so hard to build and finally activating it. You're basically converting all that theoretical potential energy into real-world kinetic energy. You are turning what you know into what you can do. Let's end on this core idea. Being good at modern math isn't about becoming a walking encyclopedia of theorems. It's about becoming an architect, someone who can use mathematical principles as their building blocks to solve real, messy, important problems. It's all about making that connection to reality.
And that brings us right back to you. This is really your call to action. You've already done the hardest part. You built that strong logical foundation. Now you have the roadmap to modernize it. So the only real question left is, what are you going to create with it?